Hey guys, in this video, we'll talk about what is proof of work and mainly talk about mining. Here is the outline of this video. I will introduce the concept of proof of work first, then we'll use an example to understand how mining works. So, proof of work is a decentralized consensus mechanism that requires members of network to expend effort solving an arbitrary mathematical puzzle to prevent anybody from gaming the system. And this work is done by mining node, or we can call miners. In last video, we have studied blockchain peer-to-peer network, and from that we have known that proof of work makes blockchain an immutable ledger. So in short, we can say proof of work is a mechanism that can make blockchain immutable by solving puzzle. We can see that this puzzle is a crucial step for proof of work. To understand proof of work, we need to understand this puzzle first. Now let's see what kind of a puzzle proof of work is solving. So this mathematical puzzle is find a nonce, and that nonce itself plus all other content in this block get hashed by SHA-256 algorithm. Then a hash will produced. This produced hash is mathematically smaller or equal to given hash. So that's a lot of terminologies. Let's check the nonce itself first. Nonce is short for number only used once. It's a 4-byte number, 32-bit, and it can be any value in this range. And this number makes the produced hash less than or equal to our target number. Remember what's inside a block? Block header and block body. So block body is a Merkle tree that contains all kinds of transaction record. And in block header, there is previous block hash, timestamp, and Merkle root of the Merkle tree. Let's zoom in the block header. This is the inside of block header. The goal of a miner is to take the current block's header and add a random number to it. Put them all together, all the stuff in this red rectangle, then use SHA-256 hash it. And this is a hash can present this block, right? And this numeric value of the hash must be smaller than the target value. So that's all it's about. So recall the first property of SHA-256. An input into a hash function will always result in same output. And we can see the original work for this miner is to hash this block header and then get a hash to represent the block. But if there is no nonce, just the timestamp and the previous block hash here and the Merkle root, no matter how we use SHA-256 hash this block header, it's always the same, right? So that's where the nonce comes in. So this time, we can say the original work for miner is nonce is 0. Then the miner hash the header to get a value and compare this hash to the target value. But if it's not equal to or smaller than, then he need to add a nonce. So therefore, miner adds this nonce to the block header and hash it. If this hash value isn't less than the target, the miner will increment the nonce by 1, add it again to the black header and hash that changed value. This process is repeatedly continuous until a hash less than target value is found. And this nonce is the only parameter the miner changes. All other remaining static. So this is the target value, and this target value ranges from 0 to 2 to the power of 224. It could be any number in this range, and the target value shows here is the maximum possible target, and this is what the hash looks like. So every time we add a nonce to block header and hash them, then we do a comparison between this hash we got to and the target value. So this is the coding demo. Yeah, you can see we need get the black hash and make a comparison to the given target. So we talked SHA-256 property before, and we cannot predict changes in the output from the change to the input. So the output is totally random. The real mining process is to try nonce from 1, then 2, 3, 4, 5, until we got a nonce that makes the block hash meet the requirement, which is the block hash smaller than or equal to the target value. And this process of getting a new block by finding a nonce is called mining. And I have put a mining demo on my GitHub. You can run it locally to experience a real mining. So that's mining, and mining is the most difficult part of proof of work, but it's not done yet. After mining, miners need to broadcast the new block and the nonce they just found to other miners on the blockchain network, so the other miners can verify. Notably, after, let's say this node is the miner found the new block. After this miner generates a new block, it does not broadcast to all nodes in the blockchain network at the same time. It only needs to broadcast to its nearby nodes, which it has established connections. So to a node in a blockchain network, there is a minimum connected node limitation for them, and let's call it P. So every node need to keep connecting, like all the time, with at least P node. As long as they are online, they need to connect at least with P nodes. So this number P is different in different blockchain, but there is always one limitation. After a miner generates a new block, it broadcasts the new block and the nonce to these P nodes. After validate the nonce, these P nodes broadcast the new block and nonce to other nodes. They are connected. So eventually the new mined block is broadcast to the whole blockchain network and added to the blockchain. And the mining of Genesis block, which is the first block in a blockchain, it's a little bit special because a Genesis block does not reference previous blocks. Hence, there is no previous hash for Genesis block. So the Genesis block is almost always hard coded into the blockchain. Unlike all the other blocks in blockchain that contain transaction, Genesis block actually does not contain any transactions. You might have a question or concern. What if two miners got a new block and a write nonce at the same time? That could happen, right? Actually, this situation happens all the time in blockchain. So let's say this is the latest block, and this is the main chain, and there are two miners got two block at the same time. Then which one will be the right block for the main blockchain? It depends on the next block. So it depends on the speed. There are other nodes and this miner himself too. So you can decide keep mining based on this block, or you can keep mining on this block. Then the block who gets the next block first, who mined the next block first, it will be the main chain. Then all other miner will join this chain and keep the mining work. You see, this situation could happen all the time, but every time the speed, the higher speed mining chain will be the main chain of this blockchain. So a block like these blue ones, they have found the right nonce, but they were not accepted by the network. Blocks like this are called orphan block, and the black chain here, it's the longest chain, and it's accepted by the network. It's called main chain. So that's the process of mining in proof of work in a high level. Thanks for watching.